Welcome back to the next instalment on Chapter 9, Straight Line Graphs. In this exercise we're going to look at the gradient and intercept, and the form of the rule we're going to look at is where it's written as y equals mx plus c. Now you may occasionally see it as y equals mx plus b, or on some graphic calculators y equals ax plus b. However, the concepts are the same. The m, or the letter in front of the x, is the coefficient, and that will stand for the gradient. And the constant term at the end, which we're calling c, will be the y-intercept. Let's have a look at our first exercise. What we're going to do is look more closely at the connection between the rule for a linear relationship and the numbers that form the gradient and the y-intercept. Now we've done a little bit of this already when we've looked at tables and we found the gradient and the y-intercept in the table. What we want to lean towards in this exercise is being able to do it solely from the graph. But at the moment we'll combine a little bit of both. Looking at the table, we can see that the x coordinates are going across by 1. So that is our run of 1. We look at our y coordinates and they are rising by 2. So as we go across from one coordinate to the next, they are changing by positive 2, and that is our rise. So when I do my rise over the run, I have 2 over 1, and that's my gradient. 2 over 1 simplified to 2. Now earlier on we also looked and we found where the y-intercept was. We found that the y-intercept appears when x is 0. So we look across the x coordinate till we find x equals 0, and that is our clue for the y-intercept. So the y value for our y-intercept is 1. Now what we need to do then is take those results and transfer them down into the rule. Y-intercept is the constant term, so it's a 1. The gradient is the m, or the coefficient. It becomes 2 down there. So y equals 2x plus 1. Now looking across at the graph, let's see where that appears. Remember earlier on, the last exercise, we needed to identify 2 points on the graph, and we found the rise and the run by drawing a triangle. So therefore my run is 1 and my rise is 2, which is what we found from the table. But the y-intercept is even easier to see. The y-intercept is whereabouts this red linear line crosses the y-axis. Right there, and its coordinate is 0, 1, which we found in the table. Alright, well what about if we're missing a few points on the table, or we're missing a few points on the line? So I have a table above there that's missing one of the points. What that is actually saying is we can look at any 2 points and we can find out the rise and the run between the 2 points. So if I was looking at the table, the first point I might be looking for might be these two, and I would find that my run is 1, my rise is 2. That's corresponding to this point here. Between the negative 1 and the 0, the x went across one place. Between negative 1 and 1, the y value went up by 2. So my rise over my run was 2 over 1. Well, what about if I used a different set of points? What about if I used these two here? Well, what that is doing is that's looking at this triangle. Now, because the gradient doesn't change, when I do my calculations of my run of 2, so my run is going across 2, and my rise is going up 4, so there's my rise here going across 4, I get my rise over run is 4 over 2. They both come out to be a gradient of 2. And then if I wish to find my y-intercept, I have a look down the y-axis, find out where it intercepts. The y value where the intercept is 1. So the constant is 1, the coefficient is 2, y equals 2x plus 1. Now remembering also that if we didn't have the 0, 1, then we'd need to find a way to look for it. either by completing the table further down or further up, or by looking at the graph. So let's do a little bit of a recap. Whereabouts did I find the y-intercept? Well, if I was looking at the table, I found the y-intercept when x equals 0. So that's where I'd find the y-intercept. If I was looking at the graph, I would find the y-intercept where the line cuts the y-axis. So that 1 would be then the y-intercept. What about finding the gradient? Whereabouts was the gradient? Well, the gradient can be found by drawing any triangle on the graph and counting the rise and the run, or from any point between any two places on the table. So I could choose 3 and 6, so 6 over 3 also equals 2. So let's try this exercise here. First thing I need to do is I need to identify 2 points on my graph. Remembering from earlier on that we need to find 2 points I know the exact location of. I'm going to choose this point down here at -1, -2, and then I'm going to choose 1, 4. So I'm drawing my triangle across and down, so that my rise is 1, 2, 3, 4, 5, 6, and my run is 2. So 6 over 2 gives me a gradient of 3. Follow that down into the rule, that's the coefficient. Now I want to find the y-intercept. So all I've got to do is have a look. There it is. The y-intercept occurs at 0, 1. That's the one part that I'm interested in. So the constant term is a 1. So my rule is that the y value is 3 lots of the x value plus 1. We'll try one more example. This time it's sloping in another direction. So what I need to be a little bit more careful here is whether it's a positive or negative gradient. So once again, I'm going to identify 2 positions on the line. I might take those 2 there. I'm going to have to draw my triangle. My rise is 3. My run is 1. However, this time the graph is pointing up towards the negative side. So my gradient is going to be a -3 over 1. Right? So -3 is my gradient. My y-intercept, well, my y-intercept, that's where it cuts through there. My y-intercept occurred at 0, 0, so the y part of that is 0. So I can write my rule now as y equals -3x plus 0. Well, to tidy that up a little bit, I'm just going to write it as y equals -3x. Now that's something you need to remember, that even though there is no constant term at the end showing, it's actually 0. Well, there are some special lines that we need to look at. In this case I have a line going straight across the page. Now, very difficult to draw a triangle putting 2 points onto that line. However, very early on we learnt that a line sloping up to the right is positive, a line sloping up to the left is negative, and a line going straight across the page has a gradient of 0. So it has a 0 gradient. But it does have a y-intercept. So the y-intercept is in this point here. The y-intercept occurs at 0, 4. So it's the 4 part that I want. So I take that 4. Take those 2 numbers, place them down into the rule. And I have y equals 0x plus 4. Once again, 0x doesn't really mean much to me. So the rule is just a plain y equals 4. A line that goes straight across at y equals 4, the rule is y equals 4. 1. In this case we have a line going vertically. Now we learned earlier that a line that goes straight up and down the page has an undefined gradient. It also has no y-intercept. So we can't use y equals mx plus c. So there is a different form of the rule that we use in this particular case. The way we would write the rule is x equals, we have a look to see where the x-intercept is, -2. So the rule is just x equals -2. And what that's actually telling us is every point on that line has its x value as -2. So for example, this point here is -2, 6. This point here is -2, 4. This point here, -2, 2. So every value in the x coordinate is -2. So let's have a quick look at some of these horizontal and vertical lines and see if we can quickly find the rules for them. I'll take the red one first. I want to find the rule for the red line going straight across the page. It's got a y-intercept, so it's going to be a y equals, no gradient, so just the constant term y equals 5. Black line going straight across the page, once again no gradient, it does have a constant term, y equals -3. Now I'm looking at the vertical lines. In this case here, I can't write it as y equals, so it just looks at x equals 3, because it goes through at 3. And then lastly, the purple line, x equals -2. So these are special lines that you may come across. Alright, finally let's look at how we can sketch using just a gradient and the y-intercept. Now what we've been doing mostly is plotting. That's where you have a table of values with 4, 5, 6 different coordinates. Put a point in each of those coordinates and you join them up with a line. That's called plotting. Sketching, we only require 2 points and then we join them up with this line that goes through those 2 points. So what we're going to do is start off with a rule. Y equals 3x minus 2. Now we've been using the gradient intercept in the format of y equals mx plus c. So we're going to take those two values in the rule and we're going to use them to form our graph. So the first value is the m, which is the gradient. So we know that our gradient equals 3. We also know that our y-intercept equals -2. Now the y-intercept is the point I'm going to start with. The y-intercept is a point that I already know exists on the line and I know where it is. It exists when the line meets the y-axis. So down here at -2. And that's because the coordinate for the y-intercept is 0, -2. The y-intercept always occurs when the x value is 0. So I have a point already. Now I need to find a second point in order to draw my line. So I'm now going to be looking at the gradient. Now I know that the gradient is the rise over the run. So I'm going to convert the number 3 into a fraction. The easiest fraction would be 3 over 1. So now I'm going to use those two values, the rise and the run, to move from my point, which is the y-intercept, to my next point on the line. So I'm going to move 3 up and 1 across. I'm not too sure which way to go. Not sure whether to go to the right or go to the left. But because the gradient is positive, I need to be having my line heading up towards the positive side. So that tells me to go right. So now I have 2 points on my line and I can sketch them by joining them up. Put a little arrowhead on them. Should really extend a little bit further, but that'll do for now. Alright, let's say for example I didn't want to choose 3 over 1. I can choose any fraction that makes the gradient equal to 3. So I could have chosen, if I wanted to, 6 over 2. And that would have meant that I would have started at the y-intercept, but I would have needed to have counted up 6. 1, 2, 3, 4, 5, 6. And then I would have needed to have gone across 2. So 6 over 2 still gets me on the line. Alright, let's look at one last example. In this case, we have a line First thing we're going to do is read the y-intercept. So in this case they're using the letter B to represent our constant term. So you can see quite clearly that it exists down at 0, -3. Now we need to know the gradient. So we find another point on the line, we do our rise over our run. So it rises up 4, goes across 7. So our rise is 4, our run is 7. So that gives us our gradient. We also know that the slope is positive in this case, so it's positive 4/7. And then finally we take those two values and put them in the rule. So our equation is y equals 4/7x, take away 3.